Yeah, I see it myself, and it bugs me. And I'll move this over as far as I can. Okay, so let's talk about what we're going to learn about tonight. As I mentioned, this is HF noise mitigation. It's really kind of a mystery to a lot of hams, especially a lot of new hams. And the way technology has changed over the years, it's not quite the problem that it used to be. There's lots of ways that we can work on trying to get our shacks and our noise environment as low as possible. So to start off with, this is a very large subject, and we're really only going to scratch the surface of this thing. We're not going to talk in detail. There's going to be no Fourier equations here dealing with noise. We're just going to talk about things in general terms and keep the lingo down, and just basically hopefully you
Hello,
guys will learn a little bit about the nature of noise. So what is noise, right? It's a word. Well, we're going to learn about what the different types of noise are and how it affects our radio, how to deal with noise. And what we're really talking about here is noise mitigation, right? It's how can we, the noise is there, how can we either mitigate the noise by eliminating it at the source or by adjusting our radio such that we can, mitigate or reduce the noise level, be able to pull the signal out of the noise. And how to use cheap AM radios. We're going to be demonstrating that here, and SDRs to track noise. And I'm very fortunate here tonight to have Dave Cole, NK7Z, out of Eugene, Oregon, who is our one of our Northwestern Division assistant directors who in charge of technical resources. And he is an expert in EMI and RFI. And I'm really pleased that Dave was on here tonight. So let's talk about what is noise, right? In radio terms, noise is basically an unwanted signal. And it's a signal that's from something other than a transmitted signal source. It does not convey any information. It's random frequency, random amplitude, and random pattern, right? So there's really there's no intelligence in it at all. Now, often people say that I'm on the radio. That's exactly what I sound like, but I don't really consider that to be noise. Electrical noise is defined as an unwanted electrical signal that falls within the passband receiver. So it's something that's being generated mechanically, and its particular frequency falls within the passband of the receiver. Noise can either be internal or external. In other words, there are different sources of noise, either internal to the radio or external, or coming from things outside of the radio. And believe it or not, the radios generate a lot of noise of their own. We're going to talk about some of those sources of noise and where they come from. This is not to be confused with interference, right? We talk about interference in our radio communications, and radio interference is defined as a form of external noise, which means to disturb or detract from. And it's really when information from one source falls outside of where it's supposed to be and winds up in the passband of your receiver. And examples of this are what are called splatter, when the signal is extra wide. When you're in single sideband, you've got the mic gain turned too high, and instead of a 3 kilohertz wide signal, you're 10 kilohertz wide. Key clicks, if you're operating a CW and you hear this click that's not only, you keep turning and the signal is still there, right? And harmonic interference, where you've got a guy that's operating on 40 meters and you can hear him just fine on 20 meters, right? That's a second harmonic. Or he's operating on 80 meters and you can hear him on 40 meters. So those are three different forms of interference. So they're basically signals that fall, are basically where they're not supposed to be. Types of noise. Well, there's natural noise. We're going to talk about natural noise. This is solar noise, noise from the sun, atmospheric noise, and there's even extraterrestrial noise, right? Noise from other galaxies and stars. And there's basically man-made or industrial noise. And there's different ways to handle these two different types of noise. Some types of noise we can control, right? You've got an arcing insulator out there or a bad splice on a wire. You can call the power company, they can come fix it. So there's some types of noise we can control. Unfortunately, if you guys are married, either husband or wife, there are some types of noise we can't control, right? Sometimes it's the significant other. Let's talk a little bit about natural noise. Natural noise is either primarily solar or cosmic. by the sun. The sun itself is a huge wideband RF source, basically from DC to light. It operates with 3 different components of noise that it puts out. There's what's called background noise. And one reason that the sun emanates such a large amount of noise is extremely hot. The surface of the sun is approximately at 6,000 degrees Kelvin. And so you've got all these atoms smashing into each other at high rates of speed and emanating noise at a very broadband level with lots and lots of power. At the same time, there's different cooler spots of the sun and warmer spots of the sun. And so these will put out different frequencies and types of noise depending on what the temperature of the sun is in that particular spot. And there's also the burst component that we've all seen, right? These ionized gases coming out at very high velocity from coronal mass ejections and solar flares. And these can really do not only cause noise, they can basically wipe out satellite communications. There's extraterrestrial noise, right? If you've got a radio telescope or even a very a VHF, UHF, Yagi, or an EME array, and you can put it on a really sensitive spectrum analyzer, you can actually see your noise level rise when you pass it across the Milky Way galaxy as we look at it from its edge. So there's also noise that's coming in from outside of our own solar system. So, I mean, there's noise, no matter where you go, you can't get away from it. It's everywhere. So let's talk a little bit about natural noise, which is primarily atmospheric. There's noise that comes from the thermal noise just from the atoms hitting each other up in the atmosphere. Our #1 source of noise in the world is lightning. There are approximately 3.5 million hits to Earth, ground to Earth lightning hits every single day, 24/7, right? Every one of those things puts out many, many megawatts of power at a wide range of frequencies. And primarily the noise that you hear when you hook up your antenna is caused by electrostatic discharge from lightning. It's the #1 lightning source, or #1 noise source in the world. If you guys that have HF Yagis and live in an area, I'm sure it's particular if you live in a nice dry area like Idaho. You get what's called snow static, right? The snow can fall down from the sky, pick up an electrostatic charge as it comes down out of the sky, and when it hits your antenna, it discharges itself into your antenna and can cause snow static. And what's bad about that is you get enough of that, you can actually build up enough of a charge that you can essentially destroy the front end of your radio. So even if you don't have lightning, like I live here in northwest Oregon, and we don't get much lightning here, but I have had a snow static where it caused a 60/9 noise level on 20 meters. Highly unusual, and I wasn't really sure what it was until I looked out the window. Saw these big flakes of snow coming down. One thing about atmospheric noise, it's mostly random frequency and polarization, and that makes it pretty hard to mitigate. But we're going to talk about some ways that you can actually do that. The fields, and this is interesting, the field strength of atmospheric noise varies inversely with the frequency, which really means the higher the frequency, the lower the atmospheric noise. So atmospheric noise, as you guys, I'm sure, have been on the air on HF, you know that it primarily affects 160 meters, 80 meters, and 40 meters, right? What we call the low bands. It affects the VHF and UHF bands much less. And one of the reasons that it's much less is that it's, as we all know, VHF and UHF signals are primarily line of sight. So you don't have any propagation ducting of the signal or bounce of the noise off the atmosphere. I mean, basically you could think of a noise source as a radio wave, only it's multiple frequency, wideband, and multiple polarization, but it still has to adhere to the same rules of propagation as all other normal radio signals do. So VHF UHF is much less severe because it's primarily line of sight. Many causes for it. There's also noise internal to the radio itself, right? Everybody's turned a radio on, especially an old tube radio, And how do you tell if it's working? You turn the volume control all the way up, right, with no signal on it, and you'll still hear a lot of noise in the radio. Modern SDR radios suffer much less from this problem. The software-defined radios, a friend of mine bought a few years ago bought a new FT3000 Yaesu, and I have both an FT2000 and an older, even older FT1000D. And the FT1000D starts putting noise out as soon as you turn the volume control up to, beyond 10%, you start hearing noise in the radio itself. And the FT3000, the new SDR radio, you can turn it almost all the way up before you hear any noise at all until you hook an antenna up. So the modern SDR radios, one of the advances of technology is the radios themselves do not generate much noise. Switching power supplies, and we're going to talk about this a little bit more. These are the wall warts that we use. Every time you buy an MFJ piece of equipment, you got to buy a wall wart to plug it in. The main thing I can say on those power supplies, and I'm going to hold up a couple examples here, is these two. Here's a couple of them here. Here's one that's a switching power supply, 12 volts, 1 1/4 amp. You plug it into the wall. And here's one also that's the same thing. This is an amp. I think it's an amp. Let's see here. What is it? An amp. Oh, it's 1.5 amps at 12 volts. These are both 12 volt. They look pretty similar. They both got prongs on them, right? The difference is this one weighs a couple of ounces. This one probably weighs 1/3 of a pound. This one's got a transformer in it to change the voltage from 110 down to 12. This one's got a switching power supply in it. And this one is really pretty quiet. I've got a third one here that's actually much smaller, but it also puts out 1.5 amps at 12 volts. This is one that was powering a LG, I think it's an LG brand, a DVD player that I had. And this sucker is extremely noisy. It's a switching power supply, and we're going to physically see just how noisy this is. So the basic thing I can tell you here, and by the way, I don't know if you can see on here, but I bought this one from Goodwill. And I can't really see it. It's upside down. There we go. Turn it right side up, right? $2.99. Can't, how can you go wrong, right? Don't buy it. Don't pay 30 bucks for these things from MFJ. Go to Goodwill and go through their bins, and $2.99. There's your ham radio cheap guy trick of the day. So the best thing to do is if you have all these wall warts, the best thing you can do obviously is to get rid of them, right? So the good ones are the heavy ones, the bad ones are the really light ones. It's best to eliminate them all together if you can, right? Use maybe a 12 volt battery or a power supply that's a quiet power supply with a common bus, and feed all your 12 volt stuff off of that. Computers, right? Computers put out a lot of RF hash, and we're going to see just how much RF hash this Dell laptop that I have is putting out here in a little bit when we do the demonstration part. Plasma televisions, right? Everybody knows when plasma televisions first came out, they were an absolute nightmare for noise. If your neighbor 3 houses down the street had a plasma TV, you're off the air. The new modern LCD ones are a lot quieter now. And they're not nearly a problem. But if you've got an old guy that's sitting there with his beer and his watching TV with his on plasma TV, he could knock you off 40 meters. Street lights, these modern LED street lights. I can actually, I've got a 40-meter Yagi here that's about almost 70 feet up. And I live in a fairly rural area here in Northwest Oregon. I'm about 25 miles northwest of Portland, and right off of Highway 30, right on the Columbia River. And I can actually aim my 40-meter Yagi to Portland, and the noise level goes up when I aim my antenna to Portland, and I turn it around away from Portland, and the noise level goes down. So a lot of these are probably LED street lights that are between me and Portland. I don't know, but I mean, that's the advantage of having a Yagi, is that you can sometimes eliminate noise just by having a good directional antenna. And we're going to talk a little bit about that later. Fluorescent lights and fluorescent light ballast, right? Those are very common noise sources. Power line noise, that's one of the problems that I have here. We're going to talk about that a little bit later. Ways you can mitigate power line noise. LEDs and grow lights. And boy, Dave NK7Z can sure talk to you about that. Right, especially in Southern Oregon, there's a lot of grow activity down there. I'm sure there is up in Washington. I don't know about Idaho. but they've become a really modern nuisance for hams because they can wipe you out for miles away. If they've got they've got multi-1,000-watt LED bulbs. Some of them are imported from China, aren't necessarily FCC type accepted, and next thing you know, you're off the air because they're putting on there. And I'm sure Dave will talk about that more at the end because he's actually got a SDR screen sample that I stole from him that shows when the lights turned off and what the noise was like at his station. The one thing to keep in mind about the man-made noise that's an advantage to us a little bit is it's mostly vertically polarized, and that's within the near field. So that helps us sometimes when we're dealing with mitigation, but it also makes vertical antennas on HF, not quite as quiet as vertically polarized antennas. We'll talk a little bit more about that too. So most of these man-made noise sources are things we can control to an extent. And as my good friend Dave down there says, it's all about going after the source. And I'll add, if possible, right? It's whatever you can do to mitigate the noise. So how do we mitigate received noise, right? You've got your 20-meter dipole up. You've got your brand new radio, right? And you turn in a single sideband signal, and sure enough, you've turned your radio on, your noise level's at S7. How can you mitigate that, right? How can you still pull the signal in? Well, the one thing you can do, of course, is get a better antenna, right? Vertical antennas are inherently noisy. So if you go out and you say, oh, I'm going to put up a butternut vertical antenna, throw some radials out there, and I should be good to go. Well, in an urban environment, verticals don't work so well because although they have a very low angle of radiation, great for working DX, they also have a tendency to pick up man-made noise. And so you'll get a lot of noise off of a vertical antenna. The Aggies are much less noisy. They use horizontal polarization, and the good thing about a Yagi, especially one with more than a couple of elements, is they're pretty directional. So if you've got noise coming in at a side angle or off the back, right, you can move the antenna around, and sometimes you can move the antenna around where the primary signal that you're trying to pick up may be a little bit reduced, but you can get a real good deep null on the noise. So once again, everybody talks about what you can do to improve your HF station, right? What's the number one thing you can do to improve your station, right? Improve the antennas. And that has to do with how you mitigate noise as well. There's no magic there at all other than just improve the antenna situation. Very important is proper bonding and grounding of all your equipment, right? Or all your feed lines coming in grounded to keep the common mode noise off there and drain off any static charges that are coming on the outside shield, right? If you get Ward Silver's book, N0AX, he talks about this extensively about a single point ground and making sure that all your feed lines are grounded as they come in, not only for noise protection, but for lightning protection as well. Ferrites, right? I use a lot of ferrites here. I have ferrites all over the place, both in the shack and on my feed lines coming in. Jim Brown, K9YC, who by the way won the ARRL Technical Service Award this year for his work with noise mitigation on coaxial cables, has an excellent information and a website. And at the very end here, we'll have a reference that you guys can go to and check out his website. All of his information he has books on this that are all free, right? You go on his website, you can download it, you can read it. And if you do buy ferrites for HF use, make sure they're made out of type 31 material. That's the type of material that you want to use for HF. If you're doing one that's only for 160 meters, you could probably use a type 77, but look for type 31 when you're trying to buy your ferrite material. And if you're trying to buy something from somebody, they don't know what material it's made out of, don't buy it, right? Ask if it's type 31. Because some will work, right? These are all have different permeabilities at different frequencies, and you want to get one that'll work good on HF. So remember that number, 31. And here's something we're going to talk about pretty extensively here is learn how to use the controls on your radio, right? Everybody knows that the radio's got a VFO knob and a volume knob, right? But how many of you guys have actually played with the other knobs that are on there to try to mitigate noise and how to bring in the signal and knock the noise down? A new guy coming down is gonna turn his radio on. He's gonna flip the switch. He's gonna turn the volume control up, turn the RF gain all the way up, if it's not all the way up, and start working stations, right? Well, that's not what you want to do, especially on the low bands, right? We talked about the noise situation on low bands, and we're going to hopefully, we're going to maybe turn some heads around here when we talk about some of the things that are counterintuitive to what you'd think you'd want to do, but are really necessary. So, and we're going to talk about learn how to use the controls on your radio. If you can, move the antennas away from their noise sources, right? I have 2 towers on my property. I've got a couple of Roan towers. One of them is right at my shack, right next to my house. My shack is actually in a separate building from my house. And I have another second tower that's back by a barn, right? Well, back at the barn, it's probably 300 feet from the nearest building where my barn is. And my horses don't make any RF noise. So there are times where I can have try to pick up a signal for example, on 20 meters, and there'll be about an S unit and a half, or sometimes 2 S units of difference in noise level between the very similar antenna. They're both 3-element Yagis. I've got a 3-element stepper at the main one and a 3-element tri-bander on the other tower. And you can be aimed at the same signal. They'll both be the same S units, but the background noise level will be about an S unit and a half higher on the one that's closer to my house. So if you can, try to move the antennas away from the, but unfortunately not everybody's lucky like I am and, has a couple of acres that can spread things out. I'm just happen to be very lucky. If you at the end, if you have lots of problems trying to mitigate noise, consider using an external noise canceller, and they're really kind of a magic box. I actually have one of them right here. We're gonna talk about how these things work, but this is an MFJ model 1026, right? This is an external noise canceller. We're gonna talk about how these things work. So here's my particular situation. This is one of my 2 towers. This is an older picture. I replaced this old TH6 here with a 3-element stepper, and then I've got a 40-meter Yagi up here in place of the 6-meter Yagi. So, but what you'll see is this little line right here that you see that comes across. That's the service entrance to my house, and it goes over my shop. I have a 2-story house over here, and it goes over my shop and goes within about 3 feet of my tower, and then heads over to the house, right? And the power lines, the 7,200 volt power lines, are just about the same height as my antennas, only they're out here maybe 50 feet away. So the power lines are very close to my antenna. My shack, by the way, is inside this building, but I don't get a lot of RF noise inside the shack because it's a completely metal building and all grounded and bonded to try to keep the noise out of the shack. Here's one way that I do. Here's a weatherhead where I have 2 of these weatherheads that bring in all the antennas. I've probably got 10 different HF antennas, and every one of the ones that operates on 40, 80, or 160 meters have these rings of RG213 coax. This particular one here has actually got 8 ferrites in it. There's 4 on this side, 4 on this side. And what we're talking about here are these little 2-inch type 31 ferrites. Hold it up here so you guys can see it. These are available at places like DigiKey or Mouser. And these are really, you want to have these things in your shack. Keep them around. They're handy. They're about $2.25. The Willamette Valley DX Club that I belong to actually bought a couple of hundred of these as a club project. And one of our guys spent the money and bought a couple hundred of them, and then we resold them to individual hams that put these in their shack to help keep RF down. So what you'll see here is this happens to be my 160-meter sloper array. And I've got this, before it goes into the shack, it gets all the noise taken off of the outside shield. This is one for my 80-meter dipole. Here, it's only got 6 on it. This is a line that comes in from my Beverage receive antenna, which we're going to talk about here in a little bit, and it also gets mitigated before it comes into the shack. So the idea is to keep the noise out of the radio room and propagating into the radio. So simplified, the mitigating noise is all about the signal to noise ratio, right? It's the power of the signal over the power of the noise. And to mitigate it, you have to either increase the level of the signal, right? Make the signals louder, or decrease the level of the noise. And so there's two different ways that one can attack this. Radio noise blankers, right? All of our HF radios have this little switch on it that says noise blanker. And you say, well, shoot, I'll just flip the switch and turn the noise blanker on. Well, I can tell you right now, unless you've got a pulse type ignition noise, for example, I have horses here. And so I've got about, I don't know, 1,200 or 1,300 feet. Maybe it's more than that. It's 8. And I got almost 1,500 feet of line that runs around the pasture, and it it's give the pulse, right? So you hear the click, click, click every time this fence charger goes off, click, click, right? And then turn the noise blanker switch on, and sure enough, poof, it's gone. And spark plugs, right? You have spark plug noise from the spark plug wires and stuff that are arcing, and or even some electrical noise. For example, you can, if you have a noisy insulator, you can sometimes get rid of that with the radio noise blanker. But once again, it's hit or miss. Does not work on atmospheric noise. Does not work on localized noise. For example, anything that's more than just a pulse, a single pulse. They just don't work for that, and don't expect them to work for that. So things that you can do to try to make your radio work better. And some of this is counterintuitive, but really think about this. Number one is, instead of using the volume control on your radio, use the RF gain control. One thing that you think about is when the RF gain is turned all the way up, what is the RF amplifier that's in the front end doing, right? It's amplifying the noise and the signal both. When it's attenuating the noise and the signal. And often the noise can be so high that it's what's triggering the AGC in your radio, the automatic gain control, not the signal. So especially on 80 meters, excuse me, turn down the RF gain and use that as your volume control. You're going to find that you're going to pull a lot of signals out of the noise that you didn't even know were there. Turn off the preamps, especially on 40 meters and 160 meters and 80 meters, right? If you've got a radio that's got a preamp little switch on it, leave it off. It's okay to use it on 20 sometimes, but generally the only time you want to use the preamp is either when you're on 15 meters, 12 meters, or 10 meters, especially 12 meters and 10 meters. But do not use the preamps on 160, do not use them on 80, and do not use them on 40, because all you're going to do is amplify the noise. The AGC is going to get a hold of it, and all you're going to hear is noise. So so leave those preamps off unless you're on one of the high bands. And once again, play with your RF gain, and if you got a lot of noise trying to pull a signal out, turn the RF gain down, see if you can hear it a little bit better. On 160 meters and 80 meters, you can go one step farther than the RF gain, and that's use the attenuator. A lot of the big contester guys will actually throw 6 to 20 dB of attenuation on the front end of the receiver to keep the noise down and to keep from overloading the AGC again. I tried this in the CW contest here, the CQ Worldwide CW contest, which I kind of operated this last about a month ago, I guess now. I'd operated it field day style with a little FT450 and cheap little Yaesu portable radio. And I found out that sure enough, I was using by the way, a 535 foot wire loop antenna. I didn't use any of my Yagis. I used a wire antenna. And sure enough, using the attenuator on 80 meters, it actually knocked the noise level down, but the signals were still there. So use the attenuator. Try using the attenuator, especially on 160 meters. A lot of guys will use up to 20 dB of attenuation on a 160 meter signal. Use narrow IF filters, right? Or a narrow IF bandwidth. If you're operating on CW, instead of make sure you've got a 500 hertz filter in there or 250 hertz CW filter. If you're on phone, instead of the 2.5 kilohertz filter, try to put in a 2 kilohertz filter or 1.8 kilohertz, right? The more of the noise you can keep out of it, think of your radio as having this pass band. And if it's this wide, you're going to pick up that much more noise, right? Because the noise is there with the signal. If you can narrow the pass band down, you'll also get rid of some of the noise. And if the signal you want is in there, you get rid of all this noise that's in the outside area that you're not really interested in. So narrow IF filters work. And if you have a radio, for example, an old Drake or an old radio that uses the old crystal filters, and if there aren't any in it, uh, find them and get them and put them in there, and you'll find out that there are differences in what the receive signal sounds when you've got a really good, narrow, sharp lattice filter in there. Add them, right? You can go out and a lot of these radios, for example, the old FT101s and the FT1000s and the um, the MPs, 1000 MPs, right? You can buy crystal filters. You can also buy roofing filters. The more filters you can put in there, the more you're going to be able to help out your noise situation. Use IF passband or the IF shift knob on your radio to narrow the tuning range. And we're going to talk about how that works in a second. But this, I can't tell you, except for the volume control and the RF gain control, the IF passband control on my radios, my HF radios, is the one that I use absolutely the most. To try to get rid of interference signals and try to narrow the bandwidth down on a side to get rid of a noise source that's on another side. And if you've got a radio, a modern SDR radio with what's called digital signal processing, DSP, for example, the ACE2FT 450 or 450D's got a little contour. It's got a DSP setting. It's got all these different controls you can play with. Learn how to use them. Play with them. The manufacturers spend a lot of time and a lot of research putting these mitigation techniques into your radios. Learn how to use them. Now here's an example of IF shift. This happens to be an ICOM graphic, but you can see here that you've got a receiver that's got not only the desired signals, and this is the passband of what the thing's trying to receive. Okay, so it's narrowed down to a signal, a little signal bandwidth here. Here's the desired signal, just a little interference signal on the side. And by shifting the IF over just a bit, now what we're doing in this case is we're shifting it over this way. You can actually throw the interference signal out of the passband, and then sometimes that helps. You can also use low noise receive antennas. I've got several receive antennas here that I use only for receive purposes on 160 meters and 80 meters. One of the antennas I have is what's called a Beverage Antenna after Harold Beveridge from the 1920s. This one's about 400 feet long and runs along a fence line along the side of my property. I've got a 5-acre lot over here that belongs to my next door neighbor. My barn is you probably see it right here. And I've got it. This runs right along the fence line. This happens to be a DX Engineering product, and it runs RG6 foam coax from the antenna. The antenna itself is made out of 450 ohm ladder line, and say it runs about 400 feet, and that's RG6 into the shack. And this is the near end, which runs into the shack. And there's also a ground rod here. It's about a 4-foot copper pipe. And at the far end, it's the same thing that terminates it in a copper pipe. And this is actually a bidirectional beverage. So this thing is steerable to either be due north or due south. My lot here that I live on runs north-south. It's about 450 feet long in this direction and about 250 feet wide in the east-west direction. It's absolutely due north and due south. So I just run the beverage antenna along here, and I get Europe on 80 meters or on 40 meters, and I can so there's sometimes I can pick up this kind of a low gain antenna, but multiple wavelengths long. It'll be less noise on here, and I've actually workstations I could not hear in my other antennas, but because this is a lower noise antenna, it's less susceptible to pick up noise. I'm actually able to pick them up. So if you have a room, think about putting up something like a beverage antenna. You can also use loops, right? If you see a lot of these magnetic loops, you can use them to not only pick up the signal, but you can also use them to null out noise. So they're kind of multi-purpose. You can also use these external noise cancelers. We talked about this a little bit more. There's several people that make them. There's the MFJ 1026 that I just talked about there, and we'll talk about this a little bit more in detail. What I particularly use that I like the most is one made by Time Wave. It's the ANC4. And the reason I like it, it's got less knobs and buttons on the front, right? These things are kind of fiddly, and the less knobs and buttons you have, the easier they're going to be to use in my book. And if you want to spend a lot of money, these, by the way, are about $175 or $200 each. And if you want to spend about $600, then you buy the one that DX Engineering sells called their NCC2. And it does pretty much the same thing. It probably works a little bit better. I know the guys that have these things that really swear by them. I'm too cheap to buy one of those, so I'll, you know, I don't mind spending a couple $100 to find out if it's going to if it's going to fix the problem. I'm not going to spend $700 or $800 to find out that it's not going to work. So, but DX Engineering's got one if you've got an unlimited bank account. So how do these noise cancelers work? Well, remember, it's all about the signal to noise ratio, right? If we cancel out the noise, if we can figure out a way to cancel the noise out that are coming in the antenna, all that's left is the signal. Wow, what a concept, right? So what cancelers use is a separate antenna that's just considered to be a noise antenna. It's a really crummy antenna. It's usually as close to the noise source as you can get. It's going to be non-resonant, and it's going to be low gain, right? You don't want it taking up the signal. You only want the antenna to pick up the noise, and we're going to explain why here in a second. I use a couple of different antennas. I've got a lot of problems with power line noise, so I use a very low fence-mounted vertical antenna with no radials. It's located probably 15 feet away from my power pole that comes into my house. And I've also got a very steep inverted V. It's kind of an NVIS antenna. That used to be an old 40-meter antenna that I had. I just took the two ends of it and took them down to where they're almost basically parallel with the tower, so they can get the signal that gets picked up by the main portion of the tower, and use that as a noise antenna. Loops work really well too. You can use them to null out the signal. We talked about those magnetic loops that you can buy. So the way these things work is, if you look at the back of it, and we're going to take a look at the 1026 here, is they've actually got several antenna ports in the back, and I think looks like it's backwards. So you have to kind of read it backwards. So it's got this connects to the radio. This connects to your, let's see, this one I guess connects to your main antenna coming in. And this one connects to the noise antenna. It says auxiliary antenna. And what that is this is where the noise antenna would attach. This goes to the radio, and this is where the main transmit antenna acts. And all of these boxes, by the way, have transmit receive switches built into them. So if you have a 100-watt radio, you can actually put these in line with the radio, between the radio and the antenna. And as soon as you key up the transmitter, it'll automatically bypass it so you won't damage it. If you've got a radio like my FT2000 that I use, it actually's got an external receive input port, and I can actually, I use it, run it through there, so I don't have to worry about the TR switching, because I'm using this on a receive antenna. But so there's basically all these things are pretty common. They have the same three little ports on them. So what they do is they feed the noise reference signal into a mixer at 180 degrees out of phase from the main signal, and they do that to cancel out the noise and leaving only the signal. So they feed the noise plus the signal in one port, the signal in the other port, and the signal plus the noise and just the noise, and then and hopefully the noise will be 180 degrees out of phase, and it'll cancel each other out. This works obviously very well on a noise that has a consistent pattern. So if you've got your next door neighbor's got a noisy wall wart that's putting out a spurs that you'll see them on an SDR display. There'll just be a bunch of spikes, right? And there's constant frequency, constant amplitude. These things will work pretty darn well on that. Man-made noise, they work pretty well on. Atmospheric noise, they don't work quite so well, but I've actually got them to work okay sometimes by doing enough fiddling on a particular signal. Now, keep in mind that both the phase and the amplitude of the noise must match both antenna inputs. So the idea is to have the signal plus the noise on one and only the noise on the second, and try to have them both be the same. And you'll find that these things have these knobs on the front where you can control the main, this is the noise antenna gain. This is the phase of the signal, so you can control the phase of the noise coming in. And this is the main antenna gain. So the idea is to get these three knobs coordinated. So the other one we talked about only has two noise, where it's got fixed on one. The time wave only has two of the knobs and not three. But here you got three knobs plus a couple other switches you can control in. to change either the frequency range to either be high or low, or the phase to either be normal or reversed. So, I mean, there's lots to play with these things. And this first knob, by the way, is the transmit receive delay position to basically say how long it's going to stay on before it switches back after you transmit. So here's a graphic example of how these things write, right? You've got the noise plus signal coming in from the main antenna into an amplifier, into a mixer. You've got the noise coming in through another amplifier, through a phase inverter, into the mixer. And the idea is you get the signal plus the noise coming in here, and technically what you get out coming the other end is signal only without the noise. And as I mentioned, the pictures here, right? There's your noise antenna gain. There's your main antenna gain. They're going to control the phase. This one's got the main antenna gain is fixed. So you've got the same phase range switch or a switch and the same frequency range switch. There's the phase, there's the phase, there's the frequency, there's the frequency. But here you've only got a noise gain. So you've got only 4 knobs instead of 6. To deal with here. You've also got another preamp you can throw in here. So I like this one because there's less knobs to fiddle with. In my particular application, I mentioned I use mine in conjunction with some low band receive antennas. So I've got the MFJ 1026, the ANC4 that are switched in through the receive external antenna port on my FT2000, so that all the TR switching is done internally into the radio, and I don't have to worry about any of the transmit receive switching being done by the noise cancelers. And I've also got an Amico preamp that I can use in conjunction on the low bands to go with the beverage antenna to bring the signal up. And I can control its frequency as well. It's a low noise preamp. So this is where we talk about what Dave's the expert in now. And Dave, I'm going to ask you to unmute, and since you're here and the guy that wrote this stuff originally, I'm going to have you kind of help out. But to reduce RFI, you must first know that RFI exists, right? This is right off of one of Dave's slides. And to know RFI exists, you must see the RFI. You have to be able to visualize it in your mind. And so you really need a different perspective than what your radio can write. You have to look, what you need to do is you need to see it and not necessarily hear it. And in short, your standard transceiver is not your friend, right? Because you've got to be able to see it, and versus just listening to the noise. So what does it take to hear and not hear, or to see RFI and not hear RFI? It takes one of these software-defined radios plus some software. It's pretty darn easy. We're going to have an example of that here. What is an SDR? As I mentioned, it's software-defined radio. It acts like a radio, but it's not like a standard radio with knobs on it, right? It's basically a little black box. I've got one right here. I'm going to pull out, unplug it, but here's an example of one. This happens to be a $20 unit that I got off eBay. It's an RTL SDR, operates from about 30 megahertz up to, I don't know, 1.2 gigahertz or something like that. Really cheap. It plugs in with a USB port. It's got a SMA connector on it here. And that's what we're going to be looking at here tonight in just a little bit. Let's see here. And this is different than a pan adapter, right? If you guys have the K3s with the little P3 pan adapter, a pan adapter will look at a very narrow spectrum of what's within the passband of the radio. But a pan adapter, I mean, an SDR can look at a much wider range of frequencies, well beyond what the passband of your radio will look at. And SDRs basically use your computer, or use a computer, to replace the innards of the radio for detection and signal formatting. Everything is done mathematically, not electronically, as in a normal radio. And that's one of the reasons that SDRs are so quiet. They don't have any amplifiers built into them, right? Every time you've got an amplifier, an RF amp or an IF amplifier in a radio, every one of those is a noise source, because what does it amplify? It amplifies the signal and the noise. So because they're just they basically use an A to D converter coming in, they can actually filter the noise out, only keep the signal, process it, and then spit it back out again. So SDR radios are by definition much better at handling noise, and they produce much less of their own noise than a conventional IF type radio. Hams like SDR devices because they're cheap, right? We're all cheap. An okay SDR will cost you about 75 bucks new at a ham fest, or about $125 new. The one I'm going to show you is about $25 on eBay. They're really cheap. However, the cheap ones lack filtering, right? There's really no filtering in them at all. So if you've got a broadcast station that's very close to you, they can get overloaded. I live in a rural area. I don't have any AM radio stations anywhere near me within miles and miles and miles of me. And these particular ones, if you want to look at what's happening on 40 meters, I can't do that with this particular cheap one, but you can with the type that Dave uses. A professional grade SDR will cost you thousands of dollars. If you buy an SDR, make sure it covers the frequency range you're interested in. And hint, as I mentioned before, the cheap ones don't cover much of the HF band. The one that I'm using here really starts on working at about 10 meters. You can download and install the software and drivers, add a broadcast band filter if you want to try to notch that AM station out that's close to your house. Start the radio, learn how to use the radio, right? That's very important. I use the SDR Sharp software package. It's free, works really well, and an RTL SDR COM dongle as the radio. Say it's, small, right? It's, who would believe that is a radio, right? Yet it is. Hang on a second. I'm going to cough here a second. There we go. Dave, NK7Z, and maybe he's updated this in the last few years, but uses an HD SDR software package and an SDR Play RSP1. Is that what you're still using, Dave?
I use the RSP 1A now.
Oh, you moved from the 1 to the 1A.
Ready to move to the RSP Duo, because then I can take two receivers. I just got a note back from the SDR Play folks. The rigs are phase coherent, so I can use Doppler shift to watch aircraft bounces. So that's a different path, different thing though.
Well, maybe you can do it for dueling grow operations.
I have enough of them here for that. I have a couple of slides I've got when you're ready for show.
Okay. So, and here's Dave, maybe where you want to take over, because this is actually an RFI capture that Dave took. And Dave, is this where you're going to start at?
Yeah, actually, I've got 3 slides, and then
all right. Let me unshare.
Okay.
And hang on a second here. Let me figure out how to unshare.
Bottom.
Stop share. There we go. That's what I was looking for. All right, Dave, you've got the COM.
Okay. Let's see. Here we go. Let's see what that looks like. Okay. That's how I started looking at RFI, was using a piece of software called S-Meter Lite. And as you can, I assume you guys can see this. Is that right, Mike?
Yes, it's coming through.
Here's the base noise level. That's S4. Here's a grow op, here's a grow op, and here's a grow op. You'll notice these two are the same. This is the guy's off time. And I actually wanted to get a little bit better than that, so I switched to an SDR. And you can see this is what your transceiver will show you. And this is what the SDR will show you. These are the various parts of the SDR. Here's the only thing I care about on the SDR. They're lightly colored in blue. The rest of everything there is RFI. All of this, all of that, all of that, and all of that are all from grow ops that are basically next door to me. Let me get this out of the way and see if I can, there. And then there, this outlines, I think that's the same slide you've got there.
Yeah.
This outlines what you're seeing with number or with little arrows showing you. This is the audio spectrum. That's the waveform of the audio. And basically you can see, and notice the S meter. You can see that a grow op, this is one that's 2.5, 3 blocks away from me. The FCC has since dealt with that one. And then a little bit of Russian over the horizon radar. Basically you can see with an SDR, like Mike was saying, you can see a heck of a lot more as far as what's happening on the radio. So with that, I can turn it back to Mike, and that's about it. You might, if you want to see more of this, go to nk7z.net. There's a ton of this stuff there. So I'll turn it back to you, Mike.
Okay. Let me get back into the presentation here. Okay, so here's the RFI capture without all the notation that Dave hid. And oops, for some reason, I'm not able to advance anymore.
Does it have focus?
Hang on, let me, uh-oh, it's telling me that I can't,
Hit F5.
well, let me get to the end of the program here. When I jumped out, it jumped out. So here's a review. If you guys want to take notes real quick, if you missed something, we'll. Okay, we all learned about receiving noise. We learned about K9YC. We saw my antennas. We talked about spark plugs. We talked about turning down the RF gain. We talked about passband. We talked about beverage antennas, loop antennas, noise cancelers, mixers, and all kinds of stuff, and beverage antennas, and characterizing it. And we're almost here. We're almost here. We're almost here. Okay, so now here's another one of Dave's slides. And here's one here that showed all of his noise. And what he did was he also then plotted it over time. And Dave, this is your slide. You want to describe
Sure.
this a little bit more in detail?
Yeah, if you look at the top window, you'll see those wide bars. Vertically is time, and that's about a 24-hour period. Horizontally is frequency, and it looks like that's the whole 40-meter band right there. So you can see the only real area that's usable are the black areas. And as you can see, the grow operation lights are very stable. They really aren't shifting much in a 24-hour period. Start at the very top, you can see where it's cool and the lights change frequency real quickly, stable down, and then for the next 24 hours, they stayed on. That's a single grow up, and that's one that's also been fixed by the FCC.
Yeah, you can see here, if you look down here, if you look on my screen, I can see it, but this is 70-20, right? So here's the bottom end of the 40-meter band. So basically he could operate the bottom 15 kilohertz.
Which is actually the only good part of the whole band anyway.
and then from there, from 70-20, all the way up to 71, looks like about 7170, right? And then a little window from 7170 to about 7220, and then from there all the way up to the top end of the band will be completely unusable. So there's an example where Dave has taken this and be able to measure it over time. And by the way, once you get these and do these screen captures like Dave talks about, we're talking a little bit more about screen captures. This provides ammunition for the FCC when you get into the mitigation problem of trying to get the FCC involved, because boy, they love that kind of stuff. So now that you see what you're up against, you can make sound plans to try to fix things, right? Use the suggestions that I mentioned to try to clean your shack up first, right? Ferrites, try to get rid of the noisy wall warts, get rid of your noisy LED bulbs if you've got them, or the CFLs. And then move outside with a loop and try to find external noises that are beyond outside of your shack. Teach others, and this is a really important thing that Dave taught me, was teach others how to see and clean up RFI. Right, since we first did this presentation at CPAC a few years ago, I've been on the road teaching the gospel about cleaning up your shack. And Dave, I want to thank you for being a part of that. Because every time you help remove an RFI source, it helps not only you, but helps somebody else too. Make captures about every month or so, right? Get your SDR, hook it up to your computer, and take a snapshot of what your RFI environment looks like, and see if there's anything new in there, right? Maybe your next door neighbor got a new hair dryer that's an Internet of Things hair dryer, and sure enough, it's putting out RFI. And every time they curl their hairs in the morning, it knocks you off 80 meters. Well, you can make a capture of that.
That's useful for, Mike.
What's that?
Document your RFI background.
Right.
Then someone moves in with a solar system and you document the difference. It's really good ammunition for the FCC.
Oh yeah, definitely. Definitely. Good point. Because RFI can pop up with zero warning. I mean, you'll be there 1 minute. I mean, I've had RFI here with all of a sudden you'll get 20/9 RFI, and then 3 seconds later it's gone, and what the heck was that? And sometimes it just don't know where it comes from. If you replace your HVAC, ask them about RFI, right? A lot of these new ones use variable speed motors that are pulse width modulated motors, and they are notoriously RF noisy. Some LED bulbs are horrific emitters of RFI, and we're going to have a little demonstration of that here in a little bit. If you buy a light bulb that generates RFI, return them and tell them why you're returning it. You're returning this thing because, yeah, it puts plenty of light out, but it puts not only light out, but RF hash. Every time you buy something, if you have enough time, ask them about their not only susceptibility to RFI, right? We don't want our 40-meter signal to start turning on our washing machine, and yet that's where we're headed to with this Internet of Things. And ask them, is this stuff been tested in an RF environment? Make noise about RFI. If you've got an RFI problem, do like Dave does, and get involved in trying to help mitigate it. In general, make RFI part of your purchasing power, right? Ask questions, and if you can, buy only RFI protected products, right? When arc fault circuit breaker, not circuit breakers, wall outlets came in, right? They came mandatory for bedroom use here a few years ago. The first ones they came out with were horrible at being susceptible to RFI. You'd get on 40 meters and it would start tripping all these GFI breakers in your house, all these arc fault ones. And there's certain ones now that you can buy. And by the way, that ARRL, if you do have a problem with anything like that, get a hold of Ed Hare, W1RFI at ARRL, and the guys in the lab there, and they spend a lot of time working with people to try to help them mitigate their RFI problems, not only receiving noise, but also things that are being susceptible to noise. And keep in mind the guy right there, Dave Cole, NK7Z, NK7Z.com, and who is our technical resource on RFI matters. So, use the talent that you've got around, both through the ARRL and we have here locally. I mentioned some things that'll help you on your path to noiselessness. Jim Brown, K9YC, go to K9YC.com. Dave has a really great website, nk7z.net. Ward Silver, N0AX, who, by the way, I'm working on this clean signal initiative you guys may have talked about in my newsletter that came out. Ward Silver is the guy that I'm working with on this. And it's going to be a paradigm shift on how transmitters are sold and how they're tested for cleanliness. So stay tuned for that if you guys read my newsletter. Ward Silver wrote the book on grounding and bonding for the radio amateur. If you don't have it, get a copy of it. The ARRL has an RFI book, right? You can get you can buy it online, and they've also got a couple of RFI web pages. One for dealing with RFI, and one that you probably better know about, but it's information for neighbors of hams, right? When you're getting into their stuff. When you're getting into their stuff and they start complaining, it's information for them as an education. So there's a lot of resources out there available for you. Here's the picture of the ARRL RFI book. If you guys didn't know, I'm the Northwestern Division Director for the ARRL, so I've got to put a plug in for them. And I want to thank you guys for the opportunity to have a commercial for the American Radio Relay League. And I'm going to thank you guys. And now it's going to be time for a demonstration here, and we won't take up a whole lot of time, but I want to show you guys a couple of things that you can do to help try to find noise. And I'm going to get out of my PowerPoint now. And I'm going to share this one now. Everybody see that? So what we're looking at here is this is the SDR Shop software package. And what I have is my RTL dongle, which is plugged into a USB port. And we're looking at about, I mentioned this is a cheap RTL USB. It goes down to about 30 megahertz. We're only going to be able to see things that are above about 30 megahertz. And I'm going to go ahead and turn this thing on. And there we are. And what I'm using for an antenna, if you guys can see it here, it's basically a coat hanger tied to a stick. and put it up there. You can see that I got it soldered into the center pin here, and it comes around. And this is what, similar to what we used to use for old 10-meter transmitter hunts. We'd drive around downtown Long Beach, California, and we'd have this hanging out of our by our hands on a window, and we'd be running around trying to find hidden transmitters on 10 meters. And you can see that I've actually got some noise right here in my I'm actually in a bedroom of my house, and I can turn around and I can actually kind of get a direction of where some of these noise sources are coming from. You see, I've got a big blob right here at about 29 megahertz that's fairly wide. And what that is, I have the foggiest idea, but every time I come in here, it's there. However, now I'm going to talk, I talked about computers, laptops can put out noise. I'm going to point this thing down on my laptop, and this is the keyboard of my laptop. And sure enough, we've got probably 20, it raises the noise floor almost 20 dB. And if I go up onto the screen, look at all the spikes noise coming from the screen of the laptop, right? I've got another thing over here. I've got a printer, which is turned on, and I'm gonna put it on the side of the printer. Look at that, right? Nice, this probably gets down into the handband. Now this particular noise source is from the switching power supply that goes with my HP printer. It's in the office here, and but there's your noise source. I'd like to know what that big blob is, but I really don't know what it is. I got other things. I've got LED bulbs in here I can put on here, but I can basically move this thing around the room, take my laptop out, you know, and go around and try to find and pinpoint where these noise sources are. Now, there's another way you can do. If you're too cheap to buy an SDR, right? You're too cheap to buy an SDR. There's another thing that you can do, and that is, and I'm going to turn this off for now, and I'm going to stop sharing. Oops. Okay, I got it. Everybody should have me back now. And so what we're going to do is I've got an AM radio, AM FM radio that I picked up at the Goodwill for like $4, right? It's battery powered AM radio. And what I'm going to do is I'm going to turn it on, and I'm going to turn on, it's what I have it set to, if you guys can hear that. It's right set to about 530 kilohertz, right at the low end of the AM broadcast band where there aren't any stations. Now I'm going to put this thing down by the keyboard of my laptop. This is the screen of the laptop. You guys hear that? Dave, can you hear that?
Yes.
Yeah, we hear it.
You hear it, okay.
Yeah,
Yes, we hear it.
Well, now we're gonna hear something else. So I've got this, what I have here is this is the wall wart. Talk about the noisiness of the wall wart, right? So this is an AC powered wall wart, puts out 12 volts. This is used to power, you know, your typical ham accessory, right? It's the $2.99 one. And what I'm going to do is I've actually got a cord here, and I'm going to plug this thing into an AC outlet. Okay, so we have a control here, and I'm going to put the radio up against it, and I've got some noise in it. The noise is actually coming in through the power line coming in. Actually, if I get it away from my laptop, that's where it's coming from, is my laptop. Now I've got it, can't really see it, but I've got it away from my laptop, and I've got it right by here, and you see that there's absolutely no noise at all. So now what I'm going to do, I feel like a snake oil salesman here. So now what I'm going to do is I'm going to plug in, this is the little switching LG power supply, and I'm going to plug it in. Right? Now listen to this thing as I unplug it, right? And because it didn't have a load on, it takes it a while for it to die. These things actually die, and they actually sound like they're dying when you turn them off. There, it finally, all the capacitors in it discharged and it turned itself off. So bad, right? Bad for your RF environment. And the last thing we're going to do is we're going to look at some LED light bulbs. I've got a little light fixture here, and I'm going to plug it in. And there's, this little cheap little transistor radio we're talking about. Makes a great little noise sensor. So here's a 75 watt. I think there's a 57 watt. They used to sell 75, but they downsized everything, so it's 57 watt incandescent bulb. Hold it up to the radio. Essentially, I'm getting too close to my laptop again, but essentially there's no noise in it at all. Now I've got a couple of different CFL bulbs here, and I've got a couple of LED bulbs, and we'll kind of compare. And you're going to find out that some of these, here's an LED bulb we're going to plug in. This is one made by General Electric, right? Oh, big brand name. It's going to be quiet, right? Well, let's see how quiet it is. Oh, guess what? The name brand bulb is noisy. Well, let's try a cheap Chinese one. That's the GE one. Here's one here made by a company called Simply Conserve, right? This is the bulbs they're actually, our local PUD was actually handing out to people when they first were trying to get people to switch over. Same type of light bulb. Oh, this one's noisy too. It's even noisier. Okay, here's another bulb. This is made by Osram. Well, guess what? Listen to that. Right? Almost no noise at all. So identical bulbs physically look the same. And one problem you'll run into with LED bulbs is, like everybody else, a lot of these big bulb manufacturers have multiple sources in China. And you can buy a GE bulb that'll be as quiet as can be. The next batch you'll get will be noisy because they buy it from a different source and stick their name on it. So you can't really go by the brand name. This one happens to be made by Osram, and it's the quietest out of all the bulbs that I have. So all of the bulbs I have in my shack are all these Osram quiet bulbs. So that's it for the presentation. Dan, I'm going to turn it over back to you, and if people have questions.
Okay, thank you very much, Mike. In your, where you got your participants, that list, at the bottom of that, you'll see a place where you can raise your hand. So if you got a question, raise your hand or put it in the chat like several people have done here. I don't see any hands raised here. Barry, you want to take the ones that's in the chat?
There's only one question, and they want to know if you can use a scope to see the noise. I assume he means an oscilloscope.
You could use a spectrum analyzer. A scope, I think, is not going to show you anything unless you've got a scope with a lot of bandwidth and a lot of gain. A spectrum analyzer would do it because you've got frequency versus amplitude to look at. A scope is going to give you time versus time versus amplitude. So it's not necessarily going to give you frequency. So you're better off using a spectrum analyzer. And you can buy one of these little these little tiny Chinese spectrum analyzers you can get now that would probably do the trick. Dave, do you have any comment on that?
Yeah, just get a software defined radio. They're 30, 40 bucks, and they're basically spectrum analyzers. If you get the SDR Play, there's an actual piece of software that's free that you can download from their site that turns it into a full-blown spectrum analyzer. And so, you spend $100, you get a really nice piece of hardware to play with.
Okay. Someone wants to know, will you buy the Osram bulbs?
I got it originally at I believe it was at Walmart.
Okay.
I picked up some low noise lights as well at the dollar store. They were $1 a piece. I took one home and tested it. It was dead quiet. I went right back and bought 40 of them from the same lot. Look for lot numbers and try to get it from the same lot number, like Medic.
Right, because Yeah, keep in mind that the manufacturers buy from plants in China, and they'll stamp different brand names on it depending on who they're making bulbs for that day. And you can have the same, I mentioned this GE bulb. You buy another GE bulb, and it may be perfectly quiet. So, I mean, the technology has certainly changed. The one thing I didn't show you guys was were CFL bulbs. CFL bulbs, most of the CFL bulbs will put out a lot of noise, much more noise even than a noisy LED bulb. But as technology has come later, I believe a lot of the ones you'll buy now. I'm converting all of my in my shop. I've got probably 24-foot, 4-foot by 2-tube fixtures, and I'm slowly starting to switch them all over to LED. And they have so far have not changed my noise floor at all. And of course, when I operate the radio contest, I try to keep all my LED bulbs in my shop off, so to try to help mitigate that.
Sometime when you're bored, Mike, take one of those very noisy power supplies, take it apart and look at the circuit board, and you'll see the empty spots for the filter.
Yeah.
They literally, they get it certified with the filter in, and then when they manufacture it, they don't stuff the parts for the filter.
Right. Okay, anyway, any more questions?
Sure. Does it matter where
people look like they're sleeping?
Does it matter where you tune the AM radio?
Yeah, I tune it all the way down to the very bottom end of the band where there's no station. Basically, you want to be in on this place where there's no station, and when I have mine, I have it right down at I think mine goes down to 530 kilohertz, and that's where I keep it tuned. And just walk around with it.
Mm-hmm.
Another thing you can do to find power is I was reading today that a lot of times power line noise, you can actually take a radio and go take it up. Every one of the power poles generally has a ground lead that runs from the neutral line down to a ground rod, and a lot of times that actually picks up and radiates the noise from an insulator. And you can actually walk by a telephone pole with that wire and put the radio by there and see if you pick up noise. And so you can tell where noise comes from as far as a power pole is concerned, right off the grounding insulator, or the grounding wire that runs down to the ground.
One more thing to remember is that AM radio you got has a loop antenna, and that's got a really sharp null.
Yes.
So point the radio until you hear nothing. Walk that way. It's really.
Yep. Okay, no more questions. Dan, it's back to you.
There's more questions. Can you put the references that were in your presentation in the chat? The presentation, the references will be shared to everybody. So
I'm going to give Dan the whole presentation so he can post it, and it'll be on there.
Okay.
If you got an invite to this, I'll be following up with the follow-up. We'll have his presentation in.
That way you guys can have all the information that we talked about tonight.
Okay. There's 2 more questions in the chat, and then we'll go to the hands.
Okay.
Dan from Bellevue wants to know, what do you think of adding an RF noise canceller into a radio? Any reason they are not built in? Separate enclosures? What's surprising about that is I've actually talked to Flex and I've talked to Elecraft about that, about why aren't you guys putting the noise cancelers in the front end of your radios, because nobody else is doing that, right? You have an external box that's required, and the answer I got back is that's a great idea. We're thinking about it. But once again with SDR, they can almost simulate that with SDR and actually pull the signal and keep the noise out of the passband. And I think that's where they're trying to do, is they're trying to be able to take and do that mathematically to pull the signal out of the noise mathematically, much as they do, for example, in FT8. I don't know if you know about FT8, but one of the advantages of FT8 is it can actually, the signal it can decode is below the noise floor. And think how difficult that must be, because it's got to be able to separate the signal from the noise mathematically. It's brilliant technology. You're working signals in FT8 that you physically cannot hear or even see on a pan adapter, and yet it's able to decode them. Okay. And someone, James from Idaho, says that Idaho Power has a noise mitigation team that will come to the house, their hams. One thing they said was, if you suspect a bad insulator on a power pole, don't hammer on the pole before they come by. And I can just picture someone hammering on a power pole and having the police called on them, because the hammering might change the source of the
noise. So
Well,
those,
and what you don't want to happen is you don't want to have you have that fix the problem, and then a week later it comes back, right?
yep,
You want to
yep.
have them be able to hear the problem, fear it. Mark KB7HDX, our vice director, actually had a problem with his house where I think it was the neutral line of the transformer was rubbing against a one of the guy wires that held the pole up, and he had a horrible noise source until they finally came and tracked that down. So I mean, it can come from all sorts of places. He had I think a 20/9 noise problem.
One of the main reasons you don't want to bang on the pole, I had a very bad noise source here on power line noise. A 7-conductor line about that diameter had 3 conductors holding it up. The rest of them had burned out. And if you pound on the pole, you'd stand a chance of dropping the high tension line.
Whoops.
Which you don't want to do, by the way.
No, no, no. Okay. Any tips on matching a noise signature to the source beyond the direction that it's coming from? The direction it's coming from.
Well, if you have a noise canceller, you want to be able to match the phase and the amplitude. So what it is, it's messing around with those knobs that are on the front of the thing to find the best setting. And by the way, once you change frequency and work another guy, you may have to go in and recalibrate those knobs. So it works well if you've got a really rare multiplier in a contest, or maybe a DX station that you want that new country, and he's on there and he's working a lot of guys, and you got enough time to sit there and fiddle with the knobs to try to get the noise down so you can actually hear him. But so I mean, for me, it's kind of a last resort, but there are people that I have been able to work in contests that I have not been able to work until I got the noise canceller set up just right. And a lot of times it's being lucky, right? I mean, is it a fix all? And the answer is no. And as everything else, your results may vary.
I think also he was asking about matching the type of problem to the noise. You can do that you can do a little bit of that. I've got some noise signatures on my website. Just go to nk7z.net and there's a RFI mitigation button.
Okay.
And then there's a whole signature file there with about 30 or 40 different noise signatures on there.
Once again, Dave's got a beautiful resource on his website.
Okay. This is a good question. Is there a way to detect power line noise when you have underground power lines?
I've never tried, but I imagine you could probably run the radio down along the ground and go back and forth in a sweeping motion.
Look for the pit, the transformer pit, and put the radio right above it, and you'll hear all sorts of noise. When you go away from it, the ground will shield it and it'll disappear. So if you get over the transformer pit, even if it's got a metal top, and you hear a lot of noise, you've got power line noise.
Okay, good. Someone wants, is it a good cheap noise canceller to buy?
The cheapest is probably either the Time Wave or the well, obviously not the one made by DX Engineering, but I mean, I bought those at Ham Swaps. If we ever see another remember the Ham Swaps we used to have, right? Well, if we ever have any more of those, I bought them at Ham Swaps for $40 to $50, and I bought some for some friends of mine and had them use it. They're readily available on the used market. I've seen them on eBay. I actually bought one at one time for $20 off of it was broken, but I had to fix it. But it was on Craigslist. Some guy had, believe it or not, one on Craigslist. So I mean, they're out there.
Okay, this is one good one. The FCC's Detroit field office used to be really responsive of problems. Now that they're closed, what is the best way to engage the FCC about problems?
Well, the ARRL has a and Dave, I'm sure, can talk about this since he knows one really well. It has this volunteer monitor program. We used to have, the ARRL used to have the official observer program to be able to listen to things and handle complaints. But now we've got a volunteer monitor program. If you've got a noise problem, you can actually send it to Riley Hollingsworth through the ARRL on the VM volunteer monitor page, or send it directly if you guys are in my division. I know a lot of you guys are in the Northwestern Division, or get a hold of your division director, and he can send the complaint to Riley Hollingsworth. I believe his call sign is K4ZDH. Is that right, David?
That's right.
K4ZDH. I'd probably get to him at K4ZDH@ARRL.net would probably do, or ARRL.org.
Yeah, the VM
And he
program
runs,
doesn't deal with noise.
like, beg your pardon?
It doesn't deal, the VM program doesn't deal with RFI. The ARRL lab does.
Oh, okay. Well, there's another good resource
You
I
want to
mentioned
call
earlier is deal
Paul.
with W1RFI at ARRL.org, Ed Hare. And if you've got up something that's putting out noise, you want to know what to do about it, he's a great resource. I get a lot of, every time you guys send something in to, as that are in my division, he sends me a copy of it. So I get a copy of everything that he sees and the responses that he has. And the ARRL lab has got some really, Zach and the other guys in there are really some very smart engineers. And they're really good at trying to work some of this stuff out. And they will also work with the manufacturers. So, you know, one of the big problems with noise generation right now are the inverters used on solar arrays, particularly the ones that solar panels that have the inverters built into the panel. And you get 20 panels up there, you've got 20 noise sources. And they've actually worked through the ARRL lab, has worked with the manufacturer, and they've actually had to go out to people's houses and change the whole solar system out to get rid of noisy inverters. And that was done through the ARRL. They're the ones that, you know, were the big gorilla that went back to the manufacturer and said, hey, you guys can't be selling stuff like this. I've got a 4.2 kilowatt solar array on top of my house here. Up in Northwest Oregon, and luckily for me, my inverter is actually underground compared to where my ham shack is. So I have no noise issues at all from my solar array.
Okay. Someone makes a comment that if you have a power company problem with the power line noise, get a pole number if you can. Go out with the AM radio and locate the pole number. Locate the pole, and then almost all poles have to have a plate on them with a pole number. Write that down and use that as a source when you call them.
Yeah, I would say every power pole has that because that's how they know which ones have you know, they have to go out and inspect those poles every so often to make sure that they're not rotted.
Right.
So every one of those has a serial number on it somehow.
Somewhere, I'm not sure if it's standardized on where, but every pole will have a marking.
Yeah, generally a little metal plate that they hammer on with some nails.
Yeah, one other thing you should do is, if you're looking for an RFI source, don't pester the power company. Make every call that you make to them count, because if every time they roll a truck, it costs them money. You don't want them rolling a truck. There was one guy here in Eugene that was starting to report to the city every street light, or not a street light, but every stoplight he went under. They're only going to work on things that cause actual problems. So if you're driving under it and it's S4, ignore it. Choose your fights well, because you only have a limited number you can use with the power company.
Yeah, I had them out here. I had a noisy transformer about a block, or actually it was probably 500 feet away from my antennas, and they actually came out and changed the transformer. It was a transformer that was noisy itself. I mean, you could physically hear the noise.
Wow, those things are 40K a piece.
Yeah. Yeah, so they actually had to come
lucky.
out and they actually changed the transformer, and my noise problem went from about S9 on 40 meters down to S2. So it was causing 6 S units of noise. And I had no idea where it was coming from. It was for a while, 40 meters was unusable. I had no idea what it was until they changed. Oh, look, they put a new transformer up and my noise is gone.
How did you locate that?
No, they located it.
Oh, they did? Okay.
I think what happened was, I think it was arcing internally a little bit, and it finally arced to the point where it burned up.
Yeah. Yeah. Take a look at your audio on the SDR. There's a little audio display. On the peaks of the top, the positive and negative excursions, if you see some squiggle lines, that's an arc. It happens right at the high and low or highest voltage points. That'll help locate some things.
Okay. Steve from Wisconsin says, for noise canceling devices, you can get them good, cheap, or fast, but you can only pick 2 of the 3.
You can only what?
Pick 2 of the 3. You can get them good, cheap, or fast, but you can only pick 2 of the 3. So that's,
yeah. I mentioned, you know, not that I own, don't own the company, but the one I've had the best success with has been the Time Wave, and they used to be made by a company. I think they were JVC, not JVC, but something like that. We made them before Time Wave bought them. So
I've had the best luck with that same unit. I have an ANC4 here as well.
Yeah, but it's the same model number. When they change companies, they the same model number. But the ANC4 is the one that I use here, and that's the reason why, you know, this one is is here and not sitting in my shack right now is because the NC4 is, this one I've gotten to work, but the other one I've been able to get to tune in and get rid of the noise faster.
Okay. I guess some people are still having problems with solar power systems. Just call Ed here and he can help you at the league.
Yes, yeah, exactly. Call Ed here, w1rfi@arrl.org.
Okay.
And just remember RFI, right? He's Mr. RFI. He's W1RFI.
Yep. And Ralph from Michigan says threatening to call the FCC has been useful with dealing with his local cable TV company. Cable TV is not supposed to leak and produce RFI at all. So I'm sure that they live in fear of having the FCC come and inspect them and find out that they're noisy and they have to replace all of their neighborhood boxes.
Mm-hmm.
So,
good to know.
A lot of the companies are very responsive if you're nice.
The cable stuff generally operates in the 800, 900 gigahertz range, especially so it's not generally a big problem on HF.
The back channel is in the HF spectrum.
Oh, okay.
Yeah, they go from 3 through 30 megs on the back channel from your cable modem back.
Oh, okay.
Yeah.
Interesting.
So
I didn't know that. I thought it was all up in the VHF, UHF microwave range.
Yeah, you'll hear it if it's leaky, and they really do want to fix it too.
Yes, they do. Okay, that's all the questions in the chat, Dan.
Okay. Well, this has been a real good presentation. And as you all know, we take this video, we send it out on the internet, and we send copies to a couple thousand hams actually, and it gets viewed a lot. I'm surprised how many times it gets hit. So this is just the beginning of who's going to be seeing this. We had a peak of about 90 people in this view in this time. Okay, is there any other questions or comments?
Well, I want to thank you guys for letting Dave and I in here and be a part of this, an honorary member of the Rat Pack for the evening. Dan, I want to thank you for what you do. As far as putting these presentations on, I know you've taken a lot of flack from some people of the league, but I've had a discussion with some people on, especially on ODV, and I think people are starting to come around. You've got some support on the ARRL and the ARRL board to, they're seeing some stuff here that they're not seeing other places, like the lifelong learning programs. You're getting as many people in your programs or more as they are in theirs. So I want to thank you for what you're doing. Not only at the division level, but now nationwide to help educate the ham population out there. So kudos to you, Dan, and your Rat Pack team.
Rat Pack was the name that one of our members, our panel member, came up with, and we all kind of liked it, so we stuck with it. I appreciate the comments there, Mike. Yeah, it has been an interesting year. We've had some pushback from the SMs. We've had some pushbacks from the directors. It's taken a while for people to see the value of what we're doing, and we're constantly changing, just constantly changing. And I'm looking forward to some interesting changes going into the first year, see how it works out. I'd like to get some more youth programs going. We have other areas we want to cover for the hams. A lot of places we haven't even touched upon yet. We've been doing this twice a week since February, actually. Actually, it started out on the last part of January. And we haven't even, amateur radio is so vast and so big. It would take quite a while to cover all the subjects.
And I'll be back on the Rat Pack channel here, hopefully in January, giving a presentation I was supposed to be doing earlier this month, which was about band planning and what the ARRL is doing on the band planning front, and some things that are going to be happening hopefully in the spring. If you guys put another commercial in, if you guys are ARRL members, and hopefully you all are, you can, if you're in the Northwestern Division, you can subscribe to my my newsletter I put out monthly and find out what I've been up to and what the league's been up to, working on behalf of amateur radio.
I might add that as long as we're throwing flowers back and forth, Mike has been, we have quite a few districts out there. What, 12 or 15?
There's
Mike?
15 divisions.
Yeah, 15 divisions. We have some directors that are difficult to work with for a variety of different reasons, and it could be not the director by himself. Some of the SMs are kind of hard to work with also, but Mike is not one of them, and he informs as well. And if you can get some of his newsletters, you will understand more what's going on at the league. So I strongly recommend doing that.
Well, and Dan, I also recommend if you guys, we have a new CEO, David Minster, NA2AA. If you've got I just got my new latest issue of QST, and he's got his first article that he wrote in there. And I want you guys to sit down and read it. Read what it says. And he's actually talks about what's coming, what's happening, and how he sees the league. As far as there's a lot of exciting things coming up. He is definitely not Howard Mickle by any stretch of the imagination. He is, I believe, gonna do great things for the ARRL. So if you get a chance, I just got mine today, and read David Minster, our new CEO's opinion on how he sees things. So with that, Dan, I'm gonna have to jump out of here. I want to thank everybody for the opportunity tonight, and hopefully we'll see you later on in this month. Thank you, Oscar. So to talk to you guys again about some things that they're looking at as far as band planning is concerned.
All right. We'll look forward to that, Mike. Appreciate it.
Okay.
Okay.
Everybody have a good evening. Have a Merry Christmas.
This is our last one for this year, correct, Dan?
No, we got one more next week, next
Okay.
Wednesday.
Okay.
And that's going to be on ARRL Public Relations.
Okay.
And Sid's going to give that one. So that'll be pretty interesting.
Okay.
Okay, folks. 73s, everyone. Appreciate you showing up tonight. And I'll get this information out to you. And in KN4 UJW, you sent a message up earlier. I'll get that information to you for the Wind League stuff. 73s, everyone. I'm going to pull the plug.
Merry Christmas.
Have a happy holiday. Merry Christmas, everybody.
73, everybody. Merry Christmas.
And
Mele Kalikimaka.
Guys, later.
Happy holidays.
Happy Festivus.
Merry Christmas.